We've seen how to use loops to ask yes or no questions and then act based on the result. But the point of a loop is to repeat something. Certainly we ask a question, but the question is used to decide whether to keep going and repeat something over and over again. What if we just want to ask a question once? And the reason we teach loops first is because it gets us a bit quicker to being able to do useful work. But there is also another feature that's a little bit, I guess, a bit easier than a loop that also involves yes or no questions. I'm just going to give a brief introduction to that here, and I'll post some code about this as well. And it's something called an if statement. And one thing something that just annoys me. It's not a big deal, but I can't stand it when people call this thing an if loop. It's not a loop, it's a statement. A loop is something that results in repetition. An if statement asks a yes or no question, and based on the answer, it either does something or it doesn't, but it never repeats it. So the only way that an if statement gets repeated is if, I don't know, it appears inside of a loop. Otherwise, it's actually very similar to a while loop that doesn't repeat. So here's an example of a very simple if statement. I've got some variables. I get down to line 14 and I ask the question, is A less than B? If the answer is yes, I go inside the body of the if statement. And if the answer is no, I skip down to the end immediately. And that's it. So there's never any repetition. At most, I will run the contents of the if statement once. But if the answer to the question is no, I'll never run the contents of the if statements. Let's just try this code out. So there it is. And it says A is less than B. And I guess just for clarity, what happens if A is greater than B? So we'll save the file, we'll try running that. And sure enough, it doesn't print anything. So that is an example of an if statement. And as I said, not an if loop because there is no looping involved. One quick semantic point. If A and B are equal, then the answer to this question is no. 10 is not less than 10. So we'll just verify that in this case, the contents of the if statement do not run. So that's the most basic example of an if statement. You might hear if statements also called if-else statements, because in this case, we have the ability to ask a question, and if the answer comes back yes, to do one thing. But what if there are mutually exclusive cases? So for example, what if we want to test if A is less than B, and if it's less, do one thing, but if it's greater, do something else? So we have that option with an if statement as well. So what I'll try here is, let's compare B to 0. So if B is greater than 0, then I'll write B is positive. And after the closing curly bracket of your if statement, you can add a second part. And of course, you can only add this if you have an if statement at the beginning. And it's called the else clause. So here we have the if, and then down here we have the else. And if B is not greater than 0, I guess that means that either B is 0 or B is negative. So I'll say B is 0 or negative. So we have, in this case, an example of an if-else structure. And when we get to line 18, we ask the question, is B greater than 0? And then we will fall into exactly one of the two cases. We will never do both, and we will never do neither of them. If the answer to the question is yes, we go inside the if, and then we skip down to the end. If the answer to the question B greater than 0 is no, we go inside the else, and then we skip down to the end. So these, we would consider them to be mutually exclusive. We only go into one of the parts, and we never go into both. So we'll try that out. And so we hear, in this case, B is positive. Okay, what happens if B was negative 10? We'll see in that case, we go inside the else, and it prints out B is 0 or negative. And I guess what happens if B is 0? And in this case, it still prints that B is 0 or negative. So that's the second case that you might see when we use if statements. And there's a third one, which is we can use if statements to break a problem down into different discrete cases. So here we've used two cases, either B is positive or B is 0 or negative. What if I want to break it down even further? I guess this time I'll use A. So I'd say, okay, if A is, let's try equals. And this is a good time to learn that if we want to ask a question about whether something is equal to something else, we ask it with two equal signs. So this, with the two equal signs, is asking a question. Is A equal to 0? If I write this, I'm saying set A to be 0. That's why we can't use one equal sign, because one equal sign is already reserved for assignment statements. So if A is equal to 0, I'll print out A is 0. And if I want to have multiple cases, I can actually have as many as I want. I can use else if, and I could say else if a is less than 0, I would print out that a is negative. And I can at the very end have an else, and the else can be, so notice how I always have to ask a question if I use the word if. At the very end of my chain of if and else if I write else, anything that gets all the way down here without a question answering yes will end up in this else. And I'll demonstrate that again in a minute. So we get to line 24. We ask the question, is a equal to 0? If the answer is yes, we go inside the if body, and then we jump all the way down to the bottom of the whole stack. We get down to line 31. We only go into, at most, one of these cases. If the answer to this question is no, we try the next condition in the list. Okay, is a less than 0? If the answer to that question is yes, go inside here, skip down to the end. If the answer to that question is no, we go into the else. So in this case, these are all mutually exclusive just like before. We will never do more than one of them. Let's try running that and see what happens. And so in this case, a is positive because we set it to the value 6 up here. Now I want to make it clear that even if the answer to more than one question would come back as yes, even if that happens, we will never ever go into more than one of those cases. So for example, let's try this. A is still equal to 6. I'll just put a equals 6 there to make it more obvious. If a is less than 10, we can print out a is less than 10. And suppose that we also ask, is a less than 100? A is less than 100. And then in the bottom case, I guess it's where it's not less than 10 and not less than 100. So if you think about this, clearly the value 6 is less than 10 and the value 6 is less than 100. But if the answer to this question comes back yes, our rules tell us that we go inside the if body and we skip down to the end. Even though the answer to this question would be yes if we asked it. If the answer to this question is yes, we do this, we never even get to this question. So we will only ever go into one of these different cases, even if maybe more than one case could apply. So we'll try that out. We can see it says a is less than 10. If I set a to be 16, well then the answer to this question comes back as no, which means we go down here, we ask this question, and it'll print that a is less than 100. So we'll try that out. We can see it prints that. So we know that it'll only ask the next question in the chain if the answer to the previous question was yes. As soon as we hit a yes answer, we execute the body of that part of the if statement, and then we go down to the bottom and we are done. We don't even continue and ask the next question. And there's one final variation. You don't have to put the catch-all else statement at the bottom if you don't want to. You could just have if and else if. And let's see what that does. So in this case, a is 16. So the answer to this question is no. The answer to this question is yes. So it'll print out a is less than 100, just like it did before. But what if the value of a is 1,000? Well, okay, 1,000 is not less than 10. So we go down here and ask this question. Is a less than 100? The answer to that is also no. So we just go down to the bottom. We don't print anything here because there is no else clause without a condition on it. And so if the answer to this question is no, then I guess we're just done. And so I'll illustrate that. And we can see there it is. We don't even, because there's no else, there is no case to fall into if the answers to all the other questions come back no. Now, if there is an else statement, then you are guaranteed that you will go into one of the different cases. If there isn't a general else statement, it is possible to go into none of the different cases if every question comes back with the answer no. But you will never ever, in any context, go into more than one of the cases inside a single stack of if and else if. You will notice that there are actually two separate if statements here. There's this one, and then down here there's a separate one. Of course, because we have two separate if statements, we could go into both of them. So just like we saw a minute ago, I guess I'll undo my change. Like we saw a minute ago, we do actually get two of the different cases. We got to compile again. We do get two of the different cases here because we execute this if statement, go into one of these cases, then we go down here and execute this completely separate and independent if statement. But inside of one stack of if and else if, we only ever go into, at most, one of the different cases.